evening, sir.
Okay, right. We'll wait for 1 more minute, then we'll start. And that is an important update today for the English class, and we'll confirm it once the people come. We'll wait for 2 more minutes.
Okay, sir.
Welcome, Rohit. Good evening. Rohit, we'll wait for 2 minutes up to like 33, 9:33. We'll wait. Let's see if anyone is joining. Else, we'll start the class. And there is an important update today for the English class. We'll discuss that too. I think Rohit, you are not audible. Like no. Like voice is not coming. I don't know why. But anyhow, it's fine. No problem. Nitish, one more thing I need to like ask you. Like, do you understand Tamil? Can you understand Tamil, Nitish? Yes, Nitish. Can you understand Tamil? I didn't get what you said. If you could text S, like please text. Okay, one, two, three. Three members have joined. Yes, we'll start the class now. Right. Yes, all of you meet yourself. We'll start the class right now. Fine. Okay. Right. So let me discuss the about the course. So the course is all about advanced process heat exchanger design data sheeting. So this is the course. Okay, so we are going to see about this heat exchanger. 1 minute. We are going to discuss about this heat exchanger, and based on the heat exchanger only we are going to design all these things like data sheeting and HDRI, and in that process design all, all these things will be based on this heat exchanger. So before getting into the heat exchanger design, we need to know certain things, certain basic things, certain basic terminologies, and certain basic concepts to understand how this one works. So yes, Dilip, Rohit, Nitish, Ravi, Rudresh. Okay, fine. Right. So before getting into this thing, like we should know like how this thing works. Right. So what am I going to do is like I'm going to write some equations, and I'm going to tell you based on the equation this things work. Okay, and we are going to discuss some terminology, basic terminologies. For that, based on the terminology, this heat exchanger design will work. Right, fine. So before writing the equation, let me ask you a question. See, it's not going to be a one person speaking session. It's going to be a discussion session. Okay, when I'm asking you a question, you can open your mouth or you can open your mic and you can answer. Only then you can easily understand all these things, right? And it will be a practice for you, because once you enter into into the interview room, when you hesitate to speak, even though you know the answer, if you hesitate to speak, you cannot be selected. You'll not be selected, because unless until you open your mouth and you speak the right answer, even if right or wrong, unless until if you don't speak, you will not get selected. So remember this. So whenever I ask any question, you can freely open your mic and you can answer. You should answer. That is how you will be selected in an interview, right? Fine. So take this as a practice session also, right? So for the heat exchanger, okay, for the heat exchanger or for the heat, what are the basic terminologies that is there? That is my question. So one second. So basic terminologies involved. So what are the basic terminologies involved? Like open your mouth, open your mic. What are the basic terminologies, or like for the heat to transfer? Heat exchanger is nothing but heat transfer. Heat transferring, okay? Heat exchanging is nothing but heat exchanging is nothing but heat transfer. And heat exchanger is the equipment to control heat exchange or heat exchanging. So for the heat to get exchanged, what are the terminologies involved? That is my question. For the heat to get exchanged, or you can say for the heat to travel from point A to point B, from here to here, what are the terminologies, or what are the things that you should consider or you should see to study this transfer of heat from one place to another? That is my question. What are the terminologies, or what is the thing that is involved? Yes. Any answer? See, again, I'll say, like, I can just teach and I can go. If I ask a question and if you think and if you answer, only then the course will be successful. Only then you can learn a lot. Otherwise, like, I can just teach and I can go. Like, I'll complete all the portions very easily, very quickly, and I'll go. But end of the day, you'll just learn whatever I'm teaching. You'll understand, but you cannot get that skill to think. That is very important for a process engineer. If you want to become a process engineer, you should think. So this question will help you to think. So think and answer. So think and answer, so that we'll see what are all the, like, whether your thoughts is right or wrong, whether it's partially right or whether it needs improvisation. We'll see. First of all, you think and answer. So for the heat to transfer from one point to another point, what are all the terminologies, or what are all the things you should consider, or what are all the things that is there for the heat to transfer? That is my question. You answer. What are the things, like, what are the basic things? Any answer? Let me write one thing. For the heat transfer to occur, you should know what is meant by heat, right? Right. So any other, likewise, what are the basic things that is involved?
Delta T.
Ravi Anand is saying delta T. Delta T is nothing but temperature difference.
Yes,
Right.
heat transfer coefficient.
Heat transfer coefficient, great. H value, heat transfer coefficient. Cooling
Surface.
and chilling. Cooling and chilling. That is heat transfer. Okay, then
Surface area.
yes, area or area of heat transfer. HT is heat transfer, area of heat transfer. Okay, then
Molar heat capacity at constant pressure.
heat capacity, CP,
Mm.
specific heat. Then
Mass.
this is mass or what?
Mass.
Hmm.
MCP delta T.
So
M.
in MCP, if Q is equal to MCP delta T, then what is this M?
M is the mass.
No, M is not the mass. Flow, Rohit told flow. Fine. So what flow actually? Yes, Rudresh.
Mass flow rate.
Yes, mass flow rate. It is not mass, it is mass flow rate. So you should not always write like M. You should always have a dot here. So this is mass flow rate. Okay, so these are the things that will consider. For those who are not know, like don't know like what is what like that, don't worry. Just I'm asking and I'll explain all these things one by one, very lightly. Ravi, you can mute, please. So I'll explain you all the things very clearly. For those who don't know, don't worry, because like I'm not a normal teacher. If one people answer okay, then this is the thing, then we'll go to the next portion. I'm not like that teacher. I'm the one who explains everything to all the people. So don't worry, I'll explain you all the things. And my explanation will be like a jigsaw puzzle. Here I'll make one thing and there I'll make one thing, and the end of the class only, or like in between, you will understand everything. You will get a clear picture. So listen carefully. What that is the one I'm saying. Okay, fine. Right. So now let me write three equations. As of now, you keep this one like this only, like all these things like this only. Let me write three equations. Okay, one is Q is equal to K A delta T. So what is K? You can write like this also. K is thermal conductivity. Right? Okay. What is Q? Rate of heat transfer. See, don't worry, like don't think, oh my god, what is this? Like he's right away going to, don't think like that. We'll get a clear picture. Just follow me. Okay, Q is equal to K delta T is one equation. Okay. Also Q is equal to HA delta T. Also Q is equal to MCP delta T. So these are the three equations by which you can,
Sir, one doubt, sir.
yes,
K del T by del X only, no, sir.
del T by del X here.
Yes, sir.
You are saying del T by del X. I'll
Ah.
come to that. I'll come to that. See,
Okay, sir.
if it is capital Q, K A delta T, okay, and you can write delta X is nothing but distance. Okay, this is temperature difference, this is distance difference. You can write like as gradient. Okay, from point A to point B, if it is 1 meter of distance, then for the distance, what is the heat transfer or what is the rate of heat transfer, like that. So what we'll do is like we'll always keep the distance, we'll always equate this to 1, that is 1 meter. So you can write delta X or you can leave, or in other words, if Q by area, or you get, I'll get to that. But we always, what we'll do is we'll equate this thing to 1 meter. So that is why you always like, we'll not include this thing. This is the main equation, q equal to ka delta t. Why we don't consider the distance? Because here distance is getting included in the area, and the distance of heat transfer will keep for unit value, that is 1 meter, always like in the formula. That is why we don't include this thing. Okay, we are neglecting this. Understood?
Yes, sir.
Yes. Fine. So we will come to that. For others, we will come to that. Okay. Right. So these are the equations which you can, equations by which you can get the rate of heat transfer. Right. As of now, I've just written a jigsaw puzzle. Like for example, if this is the picture, if this is a complete picture, I have solved this, now solved here and there, here like that. But end of the day, I'll solve here, so you'll get a complete picture. It is like that only. My class will be there, so that the class will make you think. Okay, I'll not give straight away answer. Right, fine. Now you are going to answer these questions. Okay, right. There is a scale. Okay, steel scale. Okay, there is a steel scale. So 0, like that, 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, 5 centimeter, 15 centimeter. Okay, this is a normal scale. What you're doing is you are keeping a candle here, and you are heating this part, this exactly at 0 centimeter part, right? Now my question is, at time t is equal to, here I'm using small t for time, here for here only, because there in heat exchange design we use small t for cold fluid and capital T for hot fluid. So don't get confused. Here it is time. This thing is time. Okay, t is 1 second, or you can write start from 0 second. Okay, at time t is equal to 0 second, at you can write x is equal to 1, or you can write 0 centimeter, or value of x, you can say x 0 centimeter, what will be the temperature of the point 0 is my question. Let me explain you the question. Let me explain you the question clearly. Okay, at 0 second, see time has not started, means heat has not transferred. Okay, at 0 second, at the point 0, this is x, x is nothing but this value, like this value is x, 0 1 2 3, like at 0 point, what is the temperature for this time? What is the temperature? What is the temperature? Any answer? Yes, atmospheric temperature. How? Rohit, what you are saying is right, but how? How you are saying that? Rohit, I don't know, I couldn't hear your voice, so you better type. For example, if atmospheric temperature or room temperature, you can say room temperature is 25 degrees Celsius. Okay, so here temperature will be 25 degrees Celsius only. Why? Because the heat has not yet traveled, because time is 0. If time is 1 second, then some amount of heat would have transferred. But time here it is 0 second. So at 0 second, the heat would have not traveled from this point to this point. So this point will also be in will be in room temperature. Even this whole scale will be in room temperature. If you consider point 1 at 0 time, point 2, point 3, point 4, everything will be at 25 degrees Celsius at room temperature only. Right? This is the concept. Okay. Now, my another question. Okay, at time t is equal to 1 second and at point equal to 0. Now, what will be the temperature of this point? What will be the temperature of this point? Any answer? Initially, the heat will be here only. It would have not spread here, but after time t, after 1 second, some amount of heat would have spreaded. So, what will be the temperature of this point? Any answer? Yes. What would be the temperature of this point? Or say whether the temperature will be greater than 25 or less than 25. Which answer? Or equal to 25. Which one will be there? Here, after 1 second, the temperature here will be either greater than 25 or less than 25 or equal to 25. Which option will come? Greater than 25. Why? Why? What is the reason? Heat transfer. Exactly, that is the reason. Because if 0 second, heat would have not transferred, but after 1 second, at least some amount of heat would have transferred from this point to this point, so that the heat at the point, this point, would have got increased. Say for example, that is 26 degrees Celsius, right? At after 2 seconds, at the same place 0, what would be the temperature? Say for example, 27 degrees Celsius. This is I'm saying for example. If I'm considering an experiment, conducting an experiment, and I'm keeping a thermometer here, using the thermometer, I'm writing all this reading. If it is like that, then at 3 seconds, at 0 centimeter, 28 degrees Celsius. If it is like that, every 1 second, for every 1 second, 1 degree is rising. That is, for every 1 second, 1 degree Celsius is rising. See here also 1 degree Celsius, 1 second. The difference is 1 second, 1 degree Celsius. 1 second, 1 degree Celsius. 1 second, 1 degree Celsius. Right? For this experiment, see all these things for this experiment. It might be, who knows, it might be 2 degree per second also will come, or it might be 1.7 something degree Celsius per second also come, or it might be 0.0001 degree Celsius per second will also come. But consider that in this experiment, for this experiment, it is coming as 1 degree per second. Up to now everything is clear? You have understood? Up to now?
Yes, sir.
Any doubt up to now? See, I might have straight away get into the heat transfer calculations as what is what and what is what, but that is not how I'll teach. I want everyone to understand and solve problems by your own. That is how my teaching will be. So understood? Right. Now let me give you another question. Okay, same thing. Yes. At time t equal to seconds, okay, x centimeter temperature. Okay, now at time t equal to 0, 1, 2, 3, same thing, but here instead of concentrating on this point, we are concentrating on this point, right? Here we have taken x equal to 0 centimeter. At 0 second 0 centimeter, at 1 second 0 centimeter, 2 second 0 centimeter. We have taken only this point, but here for the table 2 we are taking point number 2, sorry, point number 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. We are concentrating on this point. Okay, now answer how the temperature would be. Now answer. How the temperature would be? Say here. What the temperature at time t is equal to 0 second? What might be the temperature? You just think. You don't just listen to the test. You just think. What might be the answer? See, initial
0
class.
second 25.
Huh?
For 0 second 25, sir.
25 degrees Celsius, because we have already said, because at 0 second initially the heat will be here only, it would have not spread to the point 1. See, through the point 1 only heat will be spreading to point 2. If it is like that, then if point 1 itself is maintaining at 25 degrees Celsius, there is no possibility that the point 2 will be greater than 25 degrees Celsius or lesser than 25 degrees Celsius. Since everything is maintained at room temperature, the first point will also be in 25 degrees Celsius for second one. But for first second, after 1 second, what will be the temperature of this point 1? After 1 second, here the temperature is 26 degrees Celsius. Here for the first second, temperature is 26 here. What might be the temperature here? What is the answer?
25.
Huh?
25.
25. Why? See, you just don't just like see the notes whichever I have shared for Tamil, and you don't just say the answer. You think by yourself. Don't look into that notes or something. You will only get like the thing is like you will only like don't get the knowledge. So just like think and answer. So why 25? So Rohit says that here the temperature will increase. Okay, how? If it increase, why increase? If it is decrease, why decrease? If it is equal to 25, why 25? What is the answer? Heat transfer. Okay, heat will be getting transferred. So Rohit says increase. Heat will be getting increased. This is what Rohit says. Others. So Rohit says, according to Rohit, it will be 26 degrees Celsius. Okay. What about others? What about others? Any answer? See, just think logically. If heat needs to transfer from one point to another point, at least one point should be of increased heat. Only then heat will be getting 0 is 27 that time, 1 is 26. You are saying that this point will be 27. Sorry, at 1 second this point is 26 degrees Celsius only. This point is 26 degrees Celsius at time t is equal to 1 second. So at 1 second only, like I'm asking what is the temperature, right? Fine. So what I'm trying to say is, see, for the heat to transfer, from one point to another, at least one point must have increased temperature or higher temperature. So this is the main rule. For example, heat will get transfer if at least one point is having higher temperature. If this is T1, or you can write T0, and this is T1, T0 should be greater than T1 for the heat to get transfer. Okay, so okay, right, see here, after 1 second only, after 1 second only, this point T1 is equal to 26 degrees Celsius. So at 1 second, it takes for the heat to travel from here to here to increase the temperature at 1 degree Celsius. It take 1 second, means no way the heat will be spreaded here. So because of that, here also it will be 25 degrees Celsius only, right? So at t equal to 2 seconds, it is 27, it is 27, so it will be 26, so it will be 27 degrees Celsius, like that only, because what we have assumed 1 Celsius per second. You can also write per centimeter, 1 centimeter, you can write like that. Since I have equated it to 1, I have not included that 1 centimeter. That is what he also have asked, why we don't include that delta x here. Same thing, same reason, you can write or you can simply avoid. Okay, that is the reason I told, right? So if 1 degree Celsius per second, then the heat transfer will be 1 second, 2 second, 3, 4, likewise it will take 15 seconds to travel from this point to this point. After 15 seconds only, this point will be having 26 degrees Celsius. Up to now it is clear. So what is the rate of heat transfer here between this point and this point? So rate of heat transfer will be 1 degree Celsius per second. This is the rate of heat transfer. This is the rate of heat transfer, you can say. This is the rate of heat transfer. So, or you can say rate of increase in temperature. You can say like that also. Rate of increase in temperature. Rate of increase in temperature, right? Okay. So, now, as I've told you, this is the rate of heat transfer. Either you can calculate or you can do this with an experimental model. You can see how much time it is taking. Likewise, after fabricating the system, you will do experiment and you will vary and you will understand how it will transfer. But for industry, no way you are going to fabricate any instrument, because if you fabricate and test using trial and error method, the fixed cost will be high, very high. So that is why we will try to use equations, mathematical equations, to solve, to assume or to predict what is the method of heat transfer, or how much time it will take for the heat to transfer from one fluid to another fluid. If you talk about heat exchanger, then it is based on fluid heat transfer only, from one fluid to another fluid, how much the time will take for the transfer of heat will, or after this much time, how much the heat would have been transferred, what is the temperature. Likewise, if you need to predict, we are using this equation. See, whatever I have told is based on the experiment. If you are having any experimental setup and if you are noting the temperature after 1 second, after 2 seconds, likewise if you are keeping thermometer every 1 centimeter, and if you are noting every temperature, you can predict what is the heat rate. But in practical case, in industry, you cannot make any equipment and do trial and error method. It will increase the cost. That is why you need to predict before fabricating the equipment itself. You need to predict what is the heat transfer, how the heat transfer will occur, and what are the things you should do, and how much the heat exchanger size should be. Likewise, you need to predict. You can predict everything using these 3 equations. This is called as heat transfer equations. These equations are very important, and we are going to use all these equations in the upcoming thing, right? Yes. Now, how this equation comes. Up to now everything is clear. Now we are going to see how this equation comes. Again, I'm going to ask question, you are going to answer. Based on your answer, we will understand why this equation comes. Okay, then we'll just see about the terminologies. What exactly was, we'll see the terminologies. Okay, after seeing the terminology, we will finish. Right now, So q is rate of heat transfer or speed of heat transfer, you can say. hd is rate heat transfer, speed of heat transfer. Okay, I've already told you q is speed of heat transfer. Okay, now okay, this is a pot. Okay, and below we are making fire. Let me draw like this. Okay, right. So we are having chicken pieces. Right. Now you are going to answer, if you want to cook the chicken piece so quickly, if you want to cook the chicken piece very quickly, what you should do? That is my question. Now answer me. See here, this is the chicken piece. Okay, if you and this is the gravy, chicken gravy. If you want to cook the chicken piece very quickly, what you will do? That is my question.
Increase the temperature.
Sorry, Rudresh.
Increase the temperature.
Increase the temperature. How will you increase the temperature? See, first point is you have said increase the temperature. How will you increase the temperature? Yes, Rohit told energy, increase the energy. Fine. Here, energy is nothing but temperature. How will you increase the temperature? Increasing the temperature is very good, but how will you do that? Because
Flame. Increase flame.
increase the flame, right? Increase the temperature means increase the flame, right? Or you can say increase the source. Instead of having 2 wood logs, if I keep another 2 and if I burn that also, my flame temperature will increase, and based on the increase in source or increasing in temperature, technically we can cook the chicken very quickly, right Anand? Right Ravi Anand?
Yes.
Right. What is the another method?
Cover the vessel.
Fine. Okay, so you can cover the vessel. That is out of the box thinking actually, but cover the vessel will cook. Okay, if you cover it, it will cook very fastly. Why? It is
Vapor
actually
pressure.
it is out of the box thinking only, but why?
Boiling.
Reducing the atmospheric pressure.
Sorry,
Reducing the atmospheric pressure.
decreasing the atmospheric pressure.
Yes, sir.
Atmospheric pressure is constant. Atmospheric
Boiling point will decrease. Due
boiling point will decrease. How? Boiling point of what? Boiling point of this gravy will decrease when you
to.
cover.
Yes.
How?
By reducing the pressure.
But
No,
vapor pressure will
no. Just like just think normally. Just like don't get into chemical engineering concept. Just think basically. When you cover, it will cook fastly. How? Why? Like, have you ever been in an
because
AC?
heat was lost to the atmosphere. Now the
Exactly. Because when you cover, no loss, no heat loss.
insulation.
No heat loss will be there to the atmosphere. To the This is the main reason. If insulation, it is not insulation, but you can say you are just preventing escaping of hot gases outside. So that is the thing. So that is how you'll cook the chicken fastly. Fine. What is the other method?
Increasing the area vessel.
Huh? Sorry. Yes, yes, you are right. Tell me, tell me.
The surface, changing the vessel surface area.
Great. Increasing the surface area of the vessel. See here, heat will be traveled from here, this woodlock to this vessel, and through the vessel, like this, through the fluid, and heat will be transferred through the chicken piece through conduction, and here again convection, and again conduction, and again convection. It will be traveling like that. So for the heat to reach this chicken, it has to travel this way. But if I had a vessel which is of this much bigger size, and if I have a chicken piece, sorry, like this, 1 2 3 4 5 6, 1 2 3 4 5, you can make it here 6. Okay, if I have the chicken piece like spreaded, see it is of also like 2 liters, and this also having 2 liter capacity. I have widened, so 2 liter capacity is same. Okay, and if you heat like this, okay, same way, which one will cook faster? Condition A or condition B? Which one will cook faster?
B.
Yes, condition B. So why it will cook faster? Because here heat needs to travel through here like that, here like that. So only like heat loss will be happening here. Heat will be traveling here, but if the heat transfer area is less, same way, through the same only heat needs to travel. So the heat transfer require more time. Here transfer will be easy, because there is easy way, many, like the path is very wide enough to make the heat transfer to happen. So if you increase the surface area of the vessel, you can cook the chicken fastly. Cooking is in the sense you can make the heat transfer quicker. See, let me explain you. For example, if there is a road, okay, road, it is 1 meter, okay, that the width is 1 meter. Think that only one person can pass. Okay, I do have 10 persons with me, into 10 person with me. So one person takes 1 second to pass this road of 1 meter, or you can say 5 meter. Okay, you can say, so 5 meter, for the 5 meter to get past, every person is taking 1 second. So if there are 10 persons, means 10 seconds every, like for all the persons who get traveled, the total time will be taken will be 10 seconds. But second thing, case I do have wider road, okay, here the width is 2 meter, so also 5 meter. So now I can make 2 persons to move at the same time. So if one person is taking 1 second, another person is taking 1 second, so every 1 second 2 person is traveling. So 2 person per every second 2 person is traveling, means the overall time taken will be of 5 seconds only. So here rate of travel equal to 2 persons per second. Overall time taken will be 5 seconds. Here rate of travel will be 1 person per second. Overall time taken will be 10 seconds. Similarly, using this concept, you can understand. See, since the path is very narrow here, it needs to travel through this path only to attain here, which is past. He cannot just travel like this. It has to travel like this only. So it will take very more time to get travel. But if it is like that, then there is a separate path here. So all the chicken will cook at the same time. So heat transfer, the rate of heat transfer is more here. That is the concept. Increasing the surface area will increase the rate of heat transfer. Okay, what is the point number 3? Let me write point number 3 here. So what is point number 3? What you are answering is very great. What is point number 3? Sorry, Rudresh, you are not audible. Like I think network issues, I guess. Like your voice is a little bit shaky. Can you please type?
The type of vessel you're using.
Type of vessel that I'm using. Okay. So in case 1, think that in case 1 or case A, I am using pot. That is, you can say mud pot. Okay. In case B, I am using steel pot. MOC, material of construction. Yes. So material of construction matter. Why matter? K. That is thermal conductivity. Thermal conductivity. So based on thermal conductivity, heat transfer will be getting increased or decreased. If thermal conductivity is more, let me write clearly. If thermal conductivity is more, rate of heat transfer will be more. Okay. If area is increasing, here surface area, this surface area is less, the surface area is more. So surface area, that is heat transfer area, getting increased, rate of heat transfer also getting increased. So if area is more, that is surface area is more, Q is more. Also, what is happening here? Increase the temperature. So if the cold temperature is keeping constant and the increasing and hot temperature you are increasing, it means the difference, that is delta T, will also getting increased. So if delta T is getting increased, Q will increase, right? These are the 3 concepts. So that is what we have just kept here in the formula. K A delta T. Q is directly proportional to K, directly proportional to area, directly proportional to delta T. So this is the formula of heat transfer. If you think apart from this, nothing will come. Only these 2 things is coming. So now what is H? If you are, see, whatever we have done is for solid only, solid to solid, that is conduction only. If you want to transfer heat, see, fluid is moving here, think that it is fluid is moving here, heat transfer by the fluid to the material, here fluid to the material, heat transfer, then that you can represent in terms of H, or heat transfer coefficient. Okay, in the heat exchange that we are using, you will use fluid and you use solid. So the heat exchange between that fluid and solid, see here the thing is, not all the fluid from, or not all the heat from the flame will be transferred to the vessel. Some of the heat alone will be transferred to the vessel, some will be getting into the atmosphere as waste heat. So for example, if this is 10 kilowatt heat is produced and it is getting traveled to the vessel, nearly like 20% will be getting wasted, for example. So if 8 kilowatt is traveled here, then from the conductor, from the vessel, from the solid object to the liquid object, some amount of loss will be happening. For example, from that 8 kilowatt might be like 4 kilowatt only getting transferred. And if there is a lid here, consider if there is a lid here, from the 6 kilowatt, there might be like some losses to getting traveled from the liquid to that solid thing. So having calculated all these things, we do have one particular common constant term based on the temperature, then that is called as heat transfer coefficient. We'll see the definition one by one. So that is heat transfer coefficient. So instead of the thermal conductivity, we are using heat transfer coefficient here. And mCp delta T is nothing but mass flow rate, and Cp is specific heat capacity. We will see one by one what is what. Okay, right. Now let me tell you. Think that there is a heat exchanger. This is a double pipe heat exchanger. Okay, here this is, you can write hot fluid. It's hot fluid, and this is cold fluid. So cold in, cold out, hot in, hot out. Okay, right. Now the mass flow rate m of cold is 1 kilogram per second. Okay, mass flow rate of hot fluid equal to 1 kilogram per second. If this is the flow rate of hot fluid, then the temperature getting here, for example, if inlet temperature is, say for example, 50 degrees Celsius, and inlet temperature of cold fluid is, say for example, 25 degrees Celsius. If it is like that, then I'm getting outside, the cold fluid is getting heated to 35 degrees Celsius, and the hot fluid is getting heated to 40 or reduced to 40 degrees Celsius. If this is the case here, okay, case 1. Okay, now what I'm doing is, with the same setup, with the same heat transfer area, what I'm doing only one change here. What change I'm doing here? I am just increasing the cold fluid from 1 kilogram per second to 2 kilogram per second. Now what will happen? That is my question. This is case 1, this is case 1, this is case 2. Here cold fluid is 1 kilogram. Every second 1 kilogram will flow through here. Okay, what I'm doing is I've increased the flow rate, mass flow rate of cold fluid. So every 1 second 2 kilograms is traveling here. So if this is the thing happened, what will happen? That is my question. What will happen? What will happen? Less than 35. Which one? Cold fluid will be less than 35. You are saying that cold fluid will be, this cold one will be less than 35 degrees Celsius. How and why? And what about the hot fluid? What about the hot fluid? Cold fluid will be here 35 degrees Celsius, and here it is less than 30. What about the hot fluid? It is less than 40, less than 40 or greater than 40. Think. Here if it is 35 and it is less than 35, seems logic, but here 40 and less than 40, it is not logic, seems. Does not seem logic. Why? No sir, hot is less than 40. No, wrong. It will not be less than 40. It will be greater than 40. It will be less than 35, that is correct. It will be greater than 40. You think how? Let me explain you. Here, it is constant. Hot fluid is constant. Cold fluid, we are moving very slowly. So, heat transfer will be traveling like this. It is moving very fastly. So, if you have increased the flow rate, every 1 second 2 kilograms is flowing. Means, as I have told you, temperature difference, where yes, if temperature difference is more, rate is more, rate of heat transfer is more. So if you increase the flow rate, heat transfer rate will be getting increased. No, you're wrong. If flow rate getting increased, Q will also get increase. How? Because see here what will happen, same flow rate here, 1 kilogram per second flow rate. So at 1 second, same concept, apply scale concept here. At 1 second it will traveling 1 degree Celsius will be traveling here. Okay, see for example, it is a conveyor belt. It's a conveyor belt. Okay, it is now it is moving 1 meter per second at the rate 1 meter per second. Okay, and you are having bulkier boxes, and the surface is 1 meter exactly. Okay, and the surface is 1 meter exactly. You are having bulkier boxes. Let me draw it little bit quickly, little bit carefully. So it is having 1 meter. Okay, okay, it is having 1 meter. So every meter what at time equal to at 0 second this is happening. At 1 second what will happen? At 1 second what will happen? This box will be here. At 2 second what will happen? This box will move here. At time 2 equal to 2 second what will happen? This box will move 1 meter and this box will come here closely. After 3 seconds what will happen? This box will move exactly here, this position, and this box will come here. Like this only it will happening. So there will be no space here because it is also moving at 1 meter per second and this capacity is also 1 meter. So 1 second this box will move. So this box will come here. 1 second this, like this one. So now there is one more conveyor belt. Okay. Now there is one more conveyor belt, and this conveyor belt what is it is happening is it is moving at 2 meter per second. Every second 2 meter is moving. Every second 2 meter is moving. Now what will happen? So here 1 box per 1 second. This is the rate here. Okay, this is the rate here. But here what will happen? Since it is moving 2 meter per second, what will happen means 2 boxes will come because it is moving just like quickly it is coming down. Quickly is coming down and quickly moving because half a second only, like for 1 second it is traveling 2 meters means for half second it is traveling 1 meter, the same capacity. For the same flow rate, it is for the same rate it is this one is taking 1/2 seconds and this that is 0.5 seconds. This is taking 1 second, means every 0.5 second 1 box will come, and after 1 second 2 box would have come. After 2 seconds what will happen? 4 boxes would have come. Okay, so if flow rate is more, the transfer, if flow rate is more, the transfer will be doubled. So similarly here flow rate is more, so the transfer of heat will be doubled. So that is why mass flow rate, if it is getting increased, then rate of heat transfer will also get increased. You can write here also, mass flow rate getting increased, heat transfer rate also will get increased, right? That is why the third formula comes mCp delta T. Up to now everything is clear. Cp we will see We'll see what is CP. See, we have mentioned here. We'll see all the definitions here one by one. No issues. We'll see everything. But up to this, everything is clear. See, Q and K and Q are directly proportional. If this increase. Similarly, A, similarly T, similarly M. This is clear for you, everyone. Only two people are attending. I'm planning actually Rudresh and Rohit. Actually, what I'm planning is like this English class is yes, right, understood. This English class is like getting attended by only 5 members. So what I'm planning is like instead of having alternative classes, I'm planning for weekend classes for English batch alone. Like for example, I can take 2 hours. For example, like in the evening, like for example, in the
Sir, I'm
Sunday.
Tamil student.
Sorry,
Tamil student, sir. I am.
Rudresh, you are Tamil. Rohit, you are English, right? Rudresh, you are Tamil.
Yes, sir. That yesterday's I message you.
Okay, no problem. So
Right.
no problem, right? So Rohit,
Uh,
Yes, Rohit. Actually, what happened? Like only like few people, like 4 members are attending English class, and what I'm trying is like if it is okay to have like weekend classes alone. For example, I'll cover all the portions and all the syllabus, all the 30 hours I'll cover, and whether I can take 3 hours every weekend, if that is fine for you, Rohit. No problem. Okay, I'll ask the. I'll make a YouTube. I mean, make a WhatsApp poll, and I'll try to make it like, for example, because since only some people are only 4 people are attending, so for 4 people like having alternative classes is 3 hours is done. Yes, 3 hours I'll take, and 30 hours I'll take 10 more weekends. Okay, we'll do like that. It'll take like 10 more weekends. If possible, I'll try to accommodate Saturday also for you, so I will try to complete as soon as possible, like 3 hours at a stretch, and night time 1 hour, so 4 hour we will try to complete, so that you will not get bored, and you need not to like attend every alternative days, so it will be convenient to you also. So let me make a poll in the group, and we'll discuss it there. Okay, right. So um, up to now everything is clear. Shall we move to this topic?
yes, sir.
Yes, fine. Yes. So now this is the important thing. I'm going to explain each and every term. You need to understand it easy, like very well. Right. So let me tell you all the definitions one by one. Right. Before that, uh, let's have some 7 minutes break. We'll meet at 10:40. Right. Meanwhile, like you try to go through whatever I have thought, we'll take 7 minutes break, and we'll continue at 10:40. Yes. Meanwhile, drink water and go for restrooms and everything. We'll talk at 10:40. Yes. Okay, yes. Hope I'm audible. Okay, now we'll see the definitions and everything. Right? You are there? You are here?
Uh,
Yes. So, what is heat? What is heat?
Form of energy.
Form of energy, right? So, heat is the form of energy. So, what heat is a form of energy, right? Understandable. But practically speaking, what is heat? Practically speaking, what is heat? Definition wise, form of energy is fine. Practically speaking, what is heat actually? Light, you can say like, okay, it is a group of photons. You can say like that. But what is heat? Practically speaking, what is heat? How will you see heat, or how will you feel heat, or what is heat actually? Practically speaking, what is heat? So Rohit is saying electromagnetic wave. Then light is also an electromagnetic wave, right? Then what is the difference between electromagnetic wave or light or heat? See, electromagnetic wave is nothing but it will be having electrical field and magnetic field which is at 90 degree to each other. Electric field and magnetic field or 90 degree to each other, and that field is called as electromagnetic field. Light is one among them. But what is heat? Is heat a electromagnetic field? See, if you pass electromagnetic field to any object, it will produce heat. I'm not talking about it, but generally I'm asking what is heat. If you pass this electromagnetic radiation onto any object, for example IR radiation, if you pass through your skin or anywhere, it will create heat. So using electromagnetic radiation you can create heat. I'm not talking about that. What I'm saying is, what is heat practically? That is my question. What is heat practically?
Something
Sorry?
which increase temperature, something
Which
something which
increases
increases temperature.
something which increases the
Temperature.
temperature. Very good answer actually. Something which increases temperature. Very good answer. Something that increases temperature. As I've told you, the IR radiation will also do the same work. If you pass light radiation, IR is nothing but light radiation only, infrared radiation. It will also come under non-visible light, visible light, not visible light. You ultraviolet IR radiation. If you pass this IR radiation, it will also increase the temperature. Means this is also heat. Yes. Means this is also heat. Then what is heat? How will you define heat? It is a form of energy, right? Practically speaking, what is heat? Let me write the unit of it. It can be measured in degree Celsius or Kelvin. Someone will be writing as degree Celsius, degree Kelvin. No, only Celsius will be having degree, or Fahrenheit will be having degree. Kelvin will not having any degree, and the conversion factor is 1 degree Celsius, or you can write 0 degree Celsius equal to 273 Kelvin. This is the conversion factor you will use while solving heat exchangers. So you have to remember it. 273 Kelvin. Right. So the unit will be either joule per second or kilojoule per second or watt. You can write like that. If you talk about heat transfer or rate of heat transfer. Okay. So practically what is heat? Form of energy. Fine. Okay. How sun is producing heat? With the help of nuclear fusion reaction that is happening inside the sun. Hydrogen molecules or atoms, you can say, fusing into helium molecule. So that is happening in the sun. Because of that, heat is produced. Without sun, heat will not be produced. Okay, without sun, heat will not be produced. For example, Pluto or Neptune, it is in frozen condition. Why? There is no heat source there. So that is why everything is in frozen state. But in Venus, the temperature of Venus will be around 600 degrees Celsius. like it is like torturing heat. Why it is happening? Because it is close to the sun, and because of that sulfur rich atmosphere, the temperature of the Venus is very high. So that is the case. So if there is a source and heat is getting transferred from the source to the object, then heat or the temperature will rise. Means, what is the heat exactly? You need to understand that. What is the heat? For example, if there is a tank and there is a water, and if it is the water thing that it is traveling from, if you open the pipe, water will travel like that. Means, if you say because of the pressure it is getting traveled. What is pressure? Pressure is nothing but the molecule layer will be there like this, and all the molecules, the weight will be concentrating on the last molecule, and that is called as pressure. You can explain like that, pressure. But what is heat? How can you explain heat? Heat you cannot just like as write as temperature, like degrees Celsius. It is the unit of temperature. What is the difference between temperature and heat? Heat is nothing but simply it is a state. Heat is a form of energy that we have written already, Rohit. Heat is energy only. But what is energy? It is a state that always looks for attaining equilibrium. Or let me write it here. Heat is a state that always looks to attain equilibrium by transferring itself. That is why heat transfer is happening. Because if this point, for example, this is a sun and this is Earth as third planet. If heat is there, why it is getting traveled? Because it want to attain equilibrium. Here it is, temperature is high. Here the temperature is low. This imbalance nature cannot resist. That is why nature want to make it in equilibrium position. That is why heat is getting traveled. So heat is a state of thing that always looking to attain equilibrium by transferring itself. It should be the correct definition for heat. Why I am teaching like this? Because when you attend an interview, this people, when you like put your expert in heat exchanger design, interviewer will ask many interviewer young interviewer will ask these kind of questions. If you simply say form of energy, you'll be among 1 among 10 or 1 among 100. You'll not be getting attracted, or you'll not attract the interviewer. But if you say this definition, heat is a state that always looks to attain equilibrium by transferring itself. If you say these kind of definitions, interviewer will get attracted. That is why I am teaching these kind of things to you. See, the main purpose of the course is to educate you, also to make you pass the interview. That is the main objective. To pass the interview, your performance during the interview, you should seek attraction of the interviewer. So for these kind of things, you should be very, very clear, and you should do, or you should tell these kind of definitions. Right. Understand this definition? Yes, great, good. Right, now thermal temperature difference. Temperature difference we have already seen. What is temperature difference by this thing? So temperature difference and heat and temperature both are similar. You can just write heat transfer coefficient. So what is heat transfer coefficient? Or before getting heat transfer coefficient, just we'll take a look over thermal conductivity. So what is thermal conductivity? So it is the ability of the material to conduct heat. This is thermal conductivity. So what is thermal conductivity? For example, see you are students and I'm teaching you, I'm giving you my 100%. Someone will be having 80% capacity, someone will be having 20% capacity, someone will be having 65% capacity. So based on your capacity only you will understand the concept. Similarly, based on the capacity of the ability of the material only, it will conduct the heat. It will accept the heat. So that is called as thermal conductivity. And what is the unit? Watt per meter Kelvin you can use, but I'll always use degree Celsius. In our industry, we will use degree Celsius only. In most of the industry, we use degree Celsius only. We don't use any Kelvin unless until if it is a problem that is, we will not use Kelvin. We will use degree Celsius only. But you can write Kelvin also here. Okay. So watt per meter Kelvin. So based on the unit, what is the definition? Based on the unit, what is the definition? So it is 1 watt of heat flows per 1 degree Celsius, 1 degree Celsius of temperature gradient or delta T. Per 1 meter material. This is the definition. If it is a 1 meter material and if it is 1 degree Celsius difference between the thing and the watt traveled between this and this point, that will be given as thermal conductivity. Let me explain you very clearly. You just understand. Think that there is a rod here and the distance of the rod is exactly 1 meter, because everything we are, see here also we are just quantifying it for 1 meter. So you just understand 1 meter and it is maintained at 25 degrees Celsius and it is maintained at 26 degrees Celsius, means heat will be getting traveled from here to here, okay, higher to lower. That is a classic statement, okay, you know it. So higher to lower, if it is like that, then the rate of heat or the amount of heat that will be traveled at this condition is called as thermal conductivity, and it will be different for little bit. For example, for copper, thermal conductivity will be 400 watt per meter degree Celsius, means 400 watts of watt is equal to joule per second. 400 joules of energy will be transferred from this position to this position every second. Joule is nothing but, we have seen, joule is nothing but the rate of energy. Joule per second is nothing but the rate of energy, okay, traveling from this much to this. So that is the capacity of copper. For example, in terms of plastic, K will be somewhat like 30 watt per meter degree Celsius. In terms of plastic, if this is a plastic here, then same condition is applying, then only 30 joule per second of heat will be transferred per second. That is the exact definition of thermal conductivity. Understood? Now let's move to the other definition, mass flow rate. Mass flow rate is nothing but kilogram per second. We have seen the above thing. This equation we have seen how mass flow rate is making an effect here. Now specific heat, very very important term. Definition: heat required to raise the temperature of 1 gram of a substance or you can write by 1 degree Celsius. Here also you can write 1 Kelvin or 1 degree Celsius, what is like. That is called as specific heat. The unit is joule per gram degree Celsius. Okay, here also you can use Kelvin, but since it is general practice in industry, I'm using degree Celsius here also. Okay, what is the definition of that? Now there is a water which is of 1 gram and the water temperature is 25 degrees Celsius, room temperature. If you want to increase the temperature of the water to 26 degrees Celsius by that is 1 degree Celsius, how much joules of heat you should supply? That is the specific heat capacity. Because you know, if you are designing a heat exchanger that operates through a fluid, for the transfer of heat from this fluid to this fluid, you should know how much temperature should be given to that fluid to rise the temperature by 1 degree Celsius. These kind of data are standard based on the temperature. These are standards based on temperature. So temperature chart will be there. Based on that chart, you can write or you can get Cp, thermal conductivity, and everything. Everything will be getting varied based on the temperature. So this is the definition of the specific heat. And heat transfer coefficient. Heat transfer coefficient and thermal conductivity are very similar. The thing is, this is watt per meter degree Celsius, and heat transfer coefficient is watt per meter square degree Celsius. Only difference is extra 1 meter will come. So it is same thing. The ability of material to conduct heat 1 watt or ability of material to conduct heat. Here the ability of material to conduct heat per meter square. That is the definition here. So it is the 1 watt of heat flows per degree Celsius of temperature difference per 1 meter of material. Here 1 meter square of the fluid. Since we are having fluid here, you have to make capacity, because heat transfer coefficient will always comes for fluids or convective heat transfer only. We will explain in the upcoming classes. Means you cannot just simply layer a fluid. You have to make a capacity of fluid, that is 1 liter or 1 meter square, like that. And with this within this capacity of liquid, how the heat transfer will happening? That is why we are using for fluid heat transfer coefficient. So these are the definitions that you need. See, as of now you might have like understood 50%, but while we are discussing the problem, you will understand everything. As I told you, my teaching will always be like a jigsaw puzzle, and at the end of the, if you have understood, if you have listened carefully, at the end of the class, at the end of some classes, you will get a very clear picture and you will never forget that. That is how my teaching will be there. Right. As of now, we will complete today's class, and in the next class we are going to see many things. We are directly going to enter into the syllabus. And let me give you a poll in the WhatsApp group, and let's see like how it is coming. And also like let us see like if weekend classes is fine, we'll have Sunday classes only. Like Sunday, like 3 to 4 hours we'll have, and like 2 hours, like 2 hours and a break, and 2 hours and a break, like 2 hours, half an hour break, 2 hours, half an hour break. We'll try to make like that, and we'll try to complete portions within the stipulated time only. And no problem. Or like if you have any friends interested in English class, like let them join. We'll take alternative classes also, because like currently like only 4 members are attending English classes, and it is very difficult for me to like spend my time. No problem, I will spend my time, but every like alternatives, it is very difficult, like think from my side also. So as of now, this is my teaching. This is how my teaching will be. It will be very, very clear, and it will be very, very clarity. Concept wise, I am very, very strong, and I will explain you very, very clearly and make you also very, very strong conceptual wise, so that you will never forget the concept. And whenever the interviewer asks any question, you can just rock and answer. Right? As of now, if you have any doubt, I'm here to answer you. Else we will complete the class here. It's 11 p.m. We will complete our first class here, and we will meet. If it is okay for all of them, we'll meet on this Sunday. It will be a holiday, I guess. We'll meet, and I'll try to explain you. I'll make things accordingly. Okay, I'll explain you. Right? Any doubt, or shall we end the class today? Anything I like regarding the class, I'll put everything in the group itself before itself, so you can plan accordingly. Also, if you miss the class, no problem. Recording sessions will always be there. Even if you turn 60 years old, you can just attend the recording session. No problem. Okay. Any doubt, or shall we end the class? Rohit, Rudresh,
Sir, tomorrow Tamil class will be there,
tomorrow
sir.
Tamil classes will be there. That is for sure.
Okay,
Okay.
okay sir. Thank you.
Okay. Okay. Thank you. Thank you. Take care. Bye.
Bye, sir. Bye.